So in our previous video, we'd been looking at these 6-digit patterns, right? And even though we'd predicted from this 101 pattern that there would be a quarter of the total number of patterns that would immediately collapse, we noticed that there was actually more that immediately collapsed, right? There was 6, and then there was, 6 that shrank, and 2 of which didn't fit this ending in 101 pattern. So in this video, I wanted to see if we could find some more constant patterns that were going to make up, numbers of length, odd binary numbers of length L, and see if we could find some of those. So sort of written out a bit here to begin with, right? And so we've got these ending in 101 patterns, but now we're going to flip the next digit and we're going to look at these 001 patterns. And in particular, we're interested in the carry line right here. So if I'm adding these two numbers, like so, when I add this 1 and 1 here, even though I put 0 down here, I have to carry the next digit. And we saw when we were looking at constraints on growth of a number that the only class of numbers that added a single digit had this 1-0 pattern up front and had no carry, right? And so here with this pattern, we're only removing 2 digits. So if the number is going to shrink, we have to only add a single digit up front. So we're interested in the carry line. And there are 3 questions that we're going to ask about the carry line. We're going to ask what patterns start a carry line, what patterns continue a carry line, and what patterns end a carry line. So the pattern that starts a carry line is when we have 2 1s side by side in a binary number. And you've got an example of the addition here, right, where you're doing this 2n plus n binary addition to get that 3n step. And you can see here, right, that you have these 2 1s stacked on top of another when you have 1 and 1 side by side, right? And so when those two add, that starts a carry line, right? So it can also continue a carry line, right? You have this example here. And then you can also see that if you have this 0, 1, right, and the 1 is continuing, even though down below it's a 0, because you're adding 1 to 1, you're going to continue the carry line. And the only pattern that ends a carry line, right, is this 0, 0, where you have a 0 on top of a 0, right? And it sort of slots into the hole created by the zeros, and then the carry ends. So we can sort of explicitly talk about our pattern, right? We can say it's 1 0 0, right? ... 0 0 1. And we know for odd binary numbers of some length L, they have to start and end with a 1. So we have 2 to the L minus 2 possible patterns. And here, because we fixed 6 digits in our binary number, we have 2 to the L minus 6, right? So we want to know the fraction of patterns that equals. And I've just done a quick proof here, right, where you have, by the law of exponents, 2 to the L minus 6 over 2 to the L minus 2. You do some basic exponential addition and subtraction, right? Like these L's cancel. This 2 becomes positive because of the negative, so you have 2 to the negative 4, right? Which is 1 over 2 to the 4. So 1/16 of our patterns, right, are always going to collapse in addition to the quarter that we always found, right? So we have 4/16 plus 1/16, right, of our total patterns that are always going to collapse. So right now we're at 5/16, and this is a constant, right, for any odd binary numbers. Right? And then, if we go back to our example here, we say, okay, well, this pattern here, this 1 0 0 1 matches the rule we just found, but what about this 1 0 1 0 0 1 pattern, right? And if we examine that one a bit more closely, just do the binary addition here, right? So we see because there was no carry started, right, in this one, again, we only had a single digit added, right? So there's another class of pattern there. I don't want to run through the proof again for this, but I think it should be pretty obvious to people that, again, we can find another 1/16, right, of number patterns. So if we have 1, 0, 1, you know, going on like so, right, you know, there will be a class of pattern where this never has a carry here, so there's no carry up top. Yeah, so there's no carry up top. I actually shouldn't have written the 1/16 there, but you know, you can see how, again, we could make this fraction bigger, right? The constant numbers that collapse. So aside from that little bit at the end there, I think I'm going to leave this video here. And maybe next time I'll try and write a complete proof showing that there's always some constant fraction of binary numbers that meet this criteria, and then we can increase this 5/16 that we found, which would be pretty cool.